Hello. Hello. Good afternoon, all. Good afternoon, all. We are having session number 3 right now, and the speaker for the session number 3, Dr. Deepak Devangan sir, is with us right now. He is from Shiksha or Anusandhan, Deep University, Bhubaneswar, Odisha. He will be delivering his presentation in meanwhile. Deepak sir. Deepak sir,
हेलो सर।
yes sir, I am handing over
हाँ चालू कर दें।
for the session.
स्क्रीन विजिबल है ना सर? हाँ।
Yes sir, your screen is visible.
So good afternoon everyone, and I assume that my voice and screen is visible. So please say something so that I can understand that my voice is going through this mode.
Yes sir, Deepak sir, you are clearly audible and
Am I
your
audible?
screen is also visible. Please sir.
Hello.
Yes sir, it is audible.
Yes, thank you. So you may have gone through number of session in context of CNN and deep learning, some basics of neural network and optimization and some types of hyperparameter optimization in the last session. Now the theoretical portion has been completed, and it is time for some practical, right? Whatever you have learned prior to this session, we will be learning using this hands-on and the lab experiment kind of thing, right? So in this session, we will be covering this installation of Anaconda Python, and we will perform how an image classification can be performed for binary or multi-class classification. Then we will see how to detect the object in the given image, and it can be a custom object, any object you can take as your data, and then you perform some of the basic operation based on which you can train your network so that you can identify or you can recognize those faces or those objects in the runtime environment, right? So this PPT has nothing but two slides. The first slide is this, and this is the last slide. So because I am going to cover all the things in the practical way, so please do one by one things of whatever I am doing. You can perform in your laptop also, or if you are having desktop or laptop. So it is a completely system dependent. So we are not using the Google Colab or something like that, some AWS or some Amazon Web Platform. So here, what we are going to do, we will first install the Anaconda Python. So I am removing this. Okay, so you should go for Conda Python installation, right? So this Conda, or you can also say it Anaconda. So you first install this based on the requirement of your system and the configuration, right? So once you download this Anaconda, it is of 510 MB, and you must observe the Python version, because the compatibility issue of this Python 3.9 can impact the performance in terms of TensorFlow, or in terms of Keras or any other library like Cache, right? So we must go through this, and based on this, the system requirement should be fixed. Okay, so I have already installed this Anaconda, so I'm not going to install it. So but you can go through this Anaconda Python. We will be doing one by one. And if you get any problem during this installation, you will ask me in the chat session so that I can answer, or you can directly ask me to the voice message. Okay, so after this installation has been done, so we will be performing some of the setup. Now, because TensorFlow is provided by Google, is used for supporting language. So it is the easiest way, right? Whereas the PyTorch or and different libraries like I'm showing PyTorch. So these are different libraries for deep learning framework. You can also use this PyTorch and exposure in deep learning framework. So if you're a beginner, you must start from this TensorFlow.
Hello, Deepak sir. Sorry to interrupt you. Actually, your voice is somewhat breaking.
TensorFlow or Keras, and then you will be able to identify
Deepak
how
sir.
the things are actually happening. Okay. So you can go through this. You can go through this and yes. So this is the PyTorch. We will be having a TensorFlow and some of the cafe environment. So I suggest you to go for TensorFlow, right? So once you install this Anaconda Python, we will set up some environment. Why we are needing a setup environment? Because it might not affect your other programming or other configuration part, right? So let me start with. So once you install this Anaconda, so should I wait or you can do that? So voice issue is there. So is it clear now? Is it clear now so that I can continue with the rest of the topic?
Yes, sir. Yes, sir. It is clear. Earlier, your voice was somewhat breaking.
Okay.
Now it is clear.
Now clear. Okay, thank you. So once you install this Anaconda Python, you will be able to see like Anaconda prompt, right? So this environment, this Anaconda requires some of the setup installation. Why do we need the setup installation? Because Anaconda is capable to perform some of the operations like data science, like data visualization, and some other scientific work, right? So it is better to keep all your work in a separate environment so that it will not affect some other programs, right? So let me open this. Yes, so this is the default Anaconda prompt where you have to put some of the instruction and you have already installed. Please get it done by this. I will be putting all this commands, some complex and some easy commands, so that we can set up our environment. So the first command is that because we have installed the Conda Anaconda, so we are creating an environment using Conda create, whose name is keras underscore environment 1, and the Python language is 3.5. So 3.5 or 3.6 is compatible with all the versions. So I am using this. Okay, so this is the simplest. So you will see the base is here, right? So by default, there is no environment. So you have to set up environment. So I'm just copying and right click on it. The command will be pasted directly, right? So it is visible, right? So Conda create an hyphen name keras environment 1 Python 3.5. Okay, so probably it will take time, but you might be observing that how these things can be done, right? So yes, so it is asking for the permission whether we have to go for this or not. So probably in the first phase it may like boring, but believe me, you will be enjoying this session because all this practical environment. Now the environment has been set up. Now when you want, so see this is the base here, right? So whenever you want to activate Conda environment, you just have to type Conda activate and the environment name. So the environment name was right? So you see base here, okay, and after that you will see probably yes. Now the Keras environment, we are under the Keras environment. All the
Excuse me, sir.
installation or the setup will not affect any base program, right? So, okay, notepad is visible to me. Okay, so this is the command prompt. Okay, let me share this again. Okay, okay, no issues, no issues. You are seeing notepad over here. So I will explain how the things got happen. So probably you will see this environment. Okay, so let me again sharing my screen. So wait for 5 seconds. Let me do it again. Yes, so probably now you can visualize how the things are happening, right? Is it visible now?
Yes, sir.
Yes. So we have just created an Keras environment where we do not have to affect some of the other programs, right? So once you activate this, once you write this code, Conda create name Keras environment 3.5, you will be able to activate this environment. And whenever you want to deactivate, just you have to write Conda deactivate. So whatever the environment is currently running, it will be deactivated, right? So this is the deactivated. Now I will be again activating. So our name was Keras, right? So this is the thing. Now source activate Keras similar environment. Now you can use pip command and to install and upgrade some of the packages. Now the necessary library we will be using in our deep learning or convolution neural network based architecture. So we will install this one by one. So all this library like SciPy, this will contain some of the scientific function through which you can determine how this convolution operation or some TensorFlow operation will be executed. So these are the required, right? But for the base application, you do not require this type of application. You can just automatically install this Python Anaconda and you just start coding, right? So that does not require much. Similarly, so you should write and install one by one in your system so that you can cope up with my program execution. Okay, so yes, it will take time, not much time. Yes, so meanwhile we can discuss what we are going to do. So we will be using some image classification. As we have seen, we will do some image classification first. It will be first, and then we will go for second, custom object detection, right? So image classification, so binary image classification, it means 0 class or 1 class. Based on the input image, we try to understand what type of category it belongs to, right? Now for binary class classification, it is quite easy because a model needs only to differentiate between two classes based on the feature extracted. Okay, yes, I will throw some light on cafe. But if I focus on the cafe introduction at this time, we will be out of focus of Anaconda and some other things. So definitely I will be discussing this cafe in the last, right? Okay. So image classification is quite easy in the case of binary image classification. But for the multiple class classification, where more than 2 classes are present, the classification is quite difficult, right? See, so image classification, we will take any public data set, either it is available on some standard UCL library or in some Kaggle platform. We will be using that. After that, we will use some custom image object detection, where we will, as we have seen that the face detection is there in your session. So I will be using this face detection object. So all of these image classification or custom object detection will require some of the standard data set. If you don't find standard data set, don't worry. You can use your data set. You can set up your data set and you can train the model against those data set, right? Okay. So image classification, for image classification, we will be use tomato disease dataset Kaggle. Tomato Kaggle. So it is one of the famous data set for the image classification, or you can say multi-class classification. Right. So yes, the first command has been run. So after that, you should run like this: pip install scikit-learn. This is another famous library where you can perform some mathematical operation on the image and its variant. Either it is a binary image, grayscale image, or any color type of images. It will work on that, right? So pip install scikit-learn, scikit -learn. So you are advisable that you should do with me. Okay. So it is installed. Okay, no issues. Then pillow. I will be discussing what exactly this will do, but as this is the theoretical part, so I will not be going to discuss in much. Okay. So all installed. So then pip install h5py, h5 for the model upgradation or for model. So all the things are available in this. Because I have already installed on this my personal laptop, so it will not install it again. Okay. So some of the utility which we have to install. So I will be sharing this type of programs. Okay. So you can install these libraries. And finally, you will install this Keras. Keras is a user-friendly programming framework where you can use some of the things which are actually needed for this convolutional neural network based programming. Okay, so this is the object you have to do, starting from Conda create environment, right? Then some of the necessary packages you have to install, like yahan till pip install Keras. Okay, so this is the first phase you have to perform before going to the convolutional neural network execution. Okay, so I'm closing this and definitely I will be sharing this. Okay, right. So this is the thing which is installed in the Keras environment. So I'm closing this. Now you have to go for the Jupyter notebook. Right, when you open this Jupyter notebook, because Anaconda has installed the Jupyter notebook, if you don't find some installation packages, you just write Conda install Jupyter notebook. Some of them called Jupyter, some of them called Jupyter, so it doesn't matter. So with this command, you can install directly into the environment. So you have to copy this and you have to put in this environment. So like this. Once you press enter, all the necessary packages will be installed, right? Yes. Now, because I have already installed this, so let me take you to the programming part. Okay, so let me close this. Yes. So first thing in this session, we will be doing image classification, and this image classification will do image classification of tomato plant disease data set, right? So based on this data set, we will be identifying how this data set is going to classify, I mean the model. So I have downloaded the data set. So this is the complete data set. This plant data set, which is of 385 MB, you can download it from here, right? So you just have to type tomato disease dataset Kaggle. So the first link you will follow, and then you can download by signing in. Okay, so this is a free account. You can download it without paying any charges, right? So this is of approximately 385 MB, and it has some training and validation folder. So let me take to the folder where I've downloaded. So this is the training. Okay. So actually it was 10 type of classifications like bacterial, right? Early blight, late blight, right? Septoria leaf plot, spider mites, target spot, tomato yellow leaf curl virus, tomato mosaic virus, healthy. But this entire file containing more than 20,000 images or more than 10,000 images, which my program couldn't load because I'm running on the laptop, which is a CPU based. It is not a GPU based laptop, but still you can learn. You can train your. So what I have done, I have removed 5 of the folders to reduce the size from the training and validation. Now, first of the things you have observed here, that data set is divided into two sets, training and validation. So basically you have gone through this training and validation splitting, where you put approximately 70 to 80% data into the training so that model can learn the significant features from that, right? And once a model is learned, you will put all the data into the validation or test set, so that you can cross-examine how your model is performing, right? So in the similar way, so I will show you that how these images will look like. So this is the images. Okay, so this type of images you will see. So some of the early blight and some of the disease. So healthy tomato disease, how it look like. So this look like this. So without any marking, without any virus, without any color. So this healthy tomato plant is like this. Okay. So some of the other diseases are also there. So similarly, valid. So just keep in mind that train and validation must contain the same folders. So this is the first class bacterial spot, second class early blight, third healthy, fourth late blight, 5 leaf mold. Similarly, this validation folder will contain the same exactly 4. But the difference is that you have to use your logic how to divide this entire data set into training and testing or training on validation. So generally the authors and the scientists, they do for the k-fold validation, or they go for the 70-30, 80-20, 90-10, 60-40 type of data splittation, right? So it is up to your application and your requirement. So how you are splitting this data set. So in my part, which is the plant data set. So I have, so see, there is approximately 22 items. So for the demonstration, I have kept it like 22 and 22. So if your classes contains a balanced class, so it will be very easy for your model to identify significant features. If your class, if one or two classes of your data set might contain unbalanced data, like this might contain 3 classes, and this leaf mold may contain 10 classes, and while the other containing are 10 or 20 or uniform size of data, then it will create a problem for the model because it cannot differentiate between balanced and unbalanced type of data, right? So it is advisable to keep the data set in a balanced state, right? So this is the first thing.
Hello,
Okay, Kaggle screen is
Deepak
visible
sir,
here.
your screen has got stuck on that Kaggle website only.
Okay, no issues. So Kaggle, so you have understood what I have said, that you have to keep the training and testing validation, training and testing into the uniform size of classes. So suppose your training data set of one class will contain suppose thousand type of data. So it is advisable to keep all the 1,000 data in each of the category so that the data set is balanced, and it is same for the validation, right? So this is the type of data we have to keep, and we are going to classify our data, our input data, into 5 type of classes. So last 5 classes I have deleted and randomly because my model will not take up the load of executing this 15,000 or some images, right? See, I will be sharing my screen, task manager. So you will find, once you set the task manager, it will discuss about CPU and GPU availability, and based on that you can identify that how your system is going to work. So I consider that this classification screen is visible. Okay. Now we have to classify our tomato leaf disease into more than 5 classes or 5 classes, right? So you can write this code in your screen. Otherwise, I will be executing this screen one by one. This code. So this came from Jupyter Notebook. So either you can execute it from. So keep in mind that all the data set and files you keep it in one single folder. Okay, so from that you can click on this new, then Python 3, and this type of screen you will be seeing. Okay, so where you will execute the code, where you will write the code, and you will execute one by one. Right now, suppose I want print. Hello. So it will print hello, right? So if you press Control Enter, it will immediately start executing the output. Okay. Now if you go for the Alt plus Enter, it will open a new tab. Okay, or new cell where you can write that part. Okay. So similarly, image classification. See what libraries are we are going to use. So this is the print function. It is nothing new, and probably we will not need this. So we are importing keras. So we will be seeing two different type of importing libraries. One from the TensorFlow and one from the keras. If you have installed keras, you will directly import all the libraries, all the methods from this keras library. And if you have installed TensorFlow and installed Keras on the top of TensorFlow, then you can go through this like this, right? So first command or first library we are executing here from TensorFlow.keras preprocessing image, importing image data generator. Now, why we need data generator? Sometimes it might be possible that some of your data set target application may have less number of data, right? But we have seen that convolutional neural network or deep learning models requires a large amount of data, very large amount of data. It is not about 100 images or 200 images. If you really want to make your model learn significant features, then you supply it to the multiple number of data and ample amount of data, right? Now, but if your data has less number of data, then you can use this image data generator so that it can augment the data augmentation technique, based on which your data size can be increased. Now you can question that how the data size can be increased. Suppose we have 20 images, and how this 20 images can be transformed into 40 or 60 images. So there are different image operations like cropping, clipping, brightness, or removing noise. So some type of morphing. So this type of operation can amplify the number of data samples in your data set. So for this, we will use this image data generator. Similarly, from the models, we are importing sequential. So there are some functional model also, but as a beginner, you should use sequential because it starts with a sequence. It starts with the first line, the second line, the third line. It controls transfer from the first line to next line in a sequential order. Now, once you become a beginner, once you become an expert in this modeling design, then you can do some functional design also. You can call a function, you can call a function from any place of the program. So this is the case of models and sequential model. Now we are importing dense layer, dropout layer, activation, flatten, batch normalization. So these are the not the core part of the convolution layer network, but this will decide how the performance of your model will be increased or will be decreased, because dense layer decides how many classes you are going to classify in context of classification or object detection. Similarly, dropout, it drops some of the neurons which are not necessarily needful in the next layer of performance. Similarly, activation function like probably Dr. Rakesh Tripathi sir has explained, the sigmoid function, the ReLU function, the 10H function, based on your application requirement. Suppose it is a multi-class classification, then you will be executing the softmax function. If it is not a multi-class classification or it is a binary class classification, then you should probably use a sigmoid type of function, right? Similarly, flatten layer, a 3D, because a kernel mapping can be a 3 by 3 or n by n cross matrix and followed by 3 different color channels, right? In that case, this 3D kernel should have to be converted into a particular series of array, right? Because it has to followed by dense layer. So we can use flatten layer and this batch normalization layer, which normalize the function during the feature learning process. We will see how this will affect the performance of your model, right? So this is convolution 2D because we are operating on the 2D images. So we will need convolution 2D operation, max pooling operation. The pooling operation, you can use average pooling, you can use max pooling, you can use minimum pooling, right? Maximum pooling, average pooling, like this. Similarly, upsampling, the data sample which has been downsampled should be upsampled, right? Some ELU. So I will describing what is this ELU is meaning. So I will be explaining this. So this is the repetition. So you do not require this again. OS for directing the folder and some other things. PIL pillow. We are also needed the optimizers like Adam SGD, Adaprop, SGD grad. So there are multiple operations, right? Regularization L2 and some of the plotting technique where matplotlib is used to plot some of the graphical environment, how the performance is being used or how the performance is being carried out. Okay, so for this number of classes we have 5, right? For the 5 classes we have already seen. We are not taking the 10 classes, we are taking the 5 classes. Okay. So image rows and image columns we have by default set it to 60. Right, batch size is 32. It means maximum if you let a model to identify the features of deep learning model or tomato data set, it will execute in a batch size of 32, right? So what does it mean? At a time our model will examine 32 data samples at a time. It might be possible that your program will contain 1000 images. So you can define this batch size according to your dataset size, right? So we have training data directory and validation data directory. So this is the path I have given for the training and validation, where we have put 5 classes of training, 5 classes of validation, right? So our data is not having much data samples. So we are using this image data generator to maximize the data size during the program execution. So like it is rescaling, it is rotating the images by 30 degree, it is shifting the width range, it is shifting the height range, and it is doing some horizontal flip like this, right? So this image data generator is used to amplify the data samples size, right? So let me drink a sip of water so that in between you can ask any question. I will be answering. Yes. Right. So this is the basic setup where you have to put all the necessary libraries. Yes. Sir, please send this file by mail. Yes, definitely. And you will be able to replicate entire program and it will run definitely on your system. But you have to download the data set. Just keep in mind. Okay. Right. So here we are putting, so let me, okay. So this is the model, sequential model. So we have gone through the sequential model. We have executed the sequential model. And now this is the sequential model. So we have put the model is equal to sequential. So all the sequential operations can be executed using this model object, right? So we are adding in this sequential model, what we are adding. So I will explain one by one so that you will be having a very good idea about how this convolution operation is being carried out. So model.add, so we are adding convolution layer, right? Now this bracket is starting from this to this, okay? So what is the meaning of 32? So 32 is nothing but the number of filter, right? So your image can be n cross n. Your image size can be of n cross n or 32 cross 64 or 1064 cross 768. Okay, no issue. So we are using number of filters of 32 of size 5 cross 5. So 5 cross 5 is nothing but the kernel, or you can call it filter. And how it is going? It goes through 32 number of 5 cross 5 filter to extract the significant features from the image at the lower level and the higher level, right? So we have put it the padding same. So padding is nothing but if you have image. So let me take this padding in CNN. So you can see this padding is CNN. Yes. So what is mean by sequential model? So a sequential model is nothing but a control which transfers one by one, right? So as it is opposite of a functional model where a function can call some other function, and in that sense it will call the control transfer operation. So we are not going to deal with the functional model. We are going to implement some simple model which is the sequential. Okay, so you know this. So this padding is done. So why do we need padding? So this is the filter. So this is the filter you are going to use. Okay, yes, we are going to use this filter. So this is the 3 cross 3 filter, right? And but we have 5 cross 5 filter. So it depends on the requirement, what you're going to extract, right? And if your image is of this starting from 3 3 to this 2, but what happens when you put this 3 cross 3 matrix over this place, right? Only the center value, depending on the configuration of this kernel, only the center value will get weightage. So if this corner value, this corner value, this corner value, or all of the other corner values may not get benefited. So we use padding if we want to include this edge or this corner side of data elements, right? So padding will be same. So it is of 5 cross 5. So you can add 5 cross 5 so that the corner element will be the center. And then input shape. So input shape, we have already defined image rows, image columns here. 64, 64. And what is 3? 3 is the depth. As we have seen. Wait a minute. Yes, as we have seen, we are using the color images. So the depth is 3. If you are using the grayscale, you can use 1. Okay. Now, after this model dot add activation. So we are using relu function over here. So relu is known for the a well and famous activation function. So based on the requirement, you can apply 10x, you can apply some other function also. But relu is the most recent and the most common and famous function. So we are utilizing the relu function. Okay. Similarly, you can add multiple convolution layer, right? And here we are using max pooling. So pool size is 2 cross 2 because it will reduce the computation size and it will extract the significant features using this. So basically, it will not add any weightage to the convolutional process, but yes, it helps to reduce the computational power, right? Similarly, upsampling, because we need to upsampling. So, but you have to keep in mind that this upsampling is not needed here. Okay, because we have not downsampled yet. So what data it will upsample, right? Now, if some of the activation function and after the conversion process, some of the neurons can be dropped. If you see some of the dropout, so this is the dropout rate. So it means you are dropping 20% of the nodes or neurons, which cannot be significant, right? So it is a random basis. So the one which has the least weightage or weight in context of bias and weight, it will be dropped, right? Now the dense layer, it will have a number of nodes, and then again ReLU function. Batch normalization, I will explain how this will be done. Then some of the dropout. So repetition of this convolutional activation max pooling, then convolution activation max pooling, the number of layers in this sense, convolution activation max pooling, you will add, it will allow the model to learn more number of significant features. But it also increases the complexity at the same time, because you are convolving different filters, number of filters using this, and using this, right? So it will also create some of the complexity issues, but for the sake of simplicity, you can add a convolution activation max pooling, convolution activation max function, and then you can use dropout if you see the model is not performing very well. So I have not added this intentionally, but you can observe that this will be required only if you see the data or the model performance is not good. Okay, so this is the thing. So let me execute this. So for the first, you can either run it, or you can put control enter, or even you can run all. Okay, so let me put one chat. Is there any significance in number 256 dense layer? Yes. So whatever the number of you are putting in the dense layer, you can change it. Okay. So if I put 56, it is acceptable. If I add 9, it is acceptable. There's no harm. But the last dense layer should replicate how many number of classes you have, because ultimately this convolutional neural network based model will classify your data into the 5 categories, right? So it will not be going to categorize this into 256 categories. So you can put any random number in this place, but at the last dense layer, you will pass the number of classes. Okay, so let me run this. So I'm running this command, run. So when it is run, okay, so it has been executed. Now, because I have run this before, so if you run this first time, so it will show it one, right? It will show it one if you run it first time. Now, if it is showing some star, it means it is currently executed, right? So just make a difference between these execution and executed. Now I will execute this model which I have created, and last I have created this model summary. So it will describe how the model has been configured. So if we run this, you have to just click on this cell. So cell will be executed. So it will be executed. So this cell was executed in the 8th point, and this cell was executed in the 9th, the next. Okay, so this is the model summary. So whatever the layer we have added, it will describe how this configuration is operating on some different variables. So 64, 64, 32, right? So 32 number of channels of size 64 and 64. Like then parameter, I will explain what is the parameter. So just observe that how we are going to operate on this type of max pooling. So the max pooling operation will not do anything. It will just downsample the things. Okay, it will reduce the complexity. So based on this, you will get total parameters. Now in the last dense layer, you will see that 5 classes is there, because we have used the number of classes 5. So total parameters or something, total trainable parameters. Some of the parameters cannot be trainable. So this is, and it is non-trainable parameter. Right now, this is our second part. So in the first part, we have imported libraries. We have set the training and validation directory. We have utilized data generator class so that our data can be amplified in number of samples. And we have, yes, created a simple model. A simple model. It may not be perfect, but it is the simplest model. Okay. Now some of the programming part, because it is very easy. So here we are importing some of the optimizers like RMS prop, SD, Adam, Keras, Adam, Nadum, Adagred. So you can import multiple optimizer using this. Some of the callbacks we have to also use some model checkpoint, early stopping, reduce LR on plateau. So what is this? Model checkpoint identifies that how the model is being trained, right? And if the model performing is not improving, we can use it, we can stop that with early stopping. Now you have 10 iteration or you have 10,000 iteration, and you can see, and if you see that the model performance or the model is not performing very well after the iteration number 50. So it is going constant after the iteration number 50 to the 10,000 iteration. So it will immediately start so that the performance or the computation power can be saved, right? Similarly, reduce LR on plateau. So you know this plateau, probably in AI you have seen this in the hill climbing algorithm. So reduce LR. So learning rate can be reduced when it sees the plateau. So if there is no up and down, it can definitely going to reduce learning rate, so that we can have some performance fluctuations in that, right? So okay, so checkpoint, we have seen checkpoint, and we do this by making a plan.h5 model, right? So this is nothing to do, because it will create in the background. Okay, so we have nothing to do about this, right? So model.compile. So because we are at category multi-class category. So this is the categorical cross entropy. Otherwise, it can be binary classification or some other type of loss will be there. So we are indicating this loss is categorical type of loss, and we are using one of the optimizer from the imported optimizers like Adam. You can also choose SGD, RMS prop, or you can see choose Adagrad or Delta, like that type of optimizer. So learning rate we have set at 0.001. Now the role of learning rate is very significant. This will range from 0 to 1. Okay, in between these you can put any values. It is not like that you have to put every time .001. It is not like that. You can put any value between 0 and 1. But if you put a value which is closer to 1, the learning rate will be what? So let me take this 0.1. Okay, so some other type of learning rate I can choose. So don't get bored, because once it will run, you will identify that how this programming portion is done. Okay, 002. Right. So I have explained that between 0 and 1, you can put any learning rate. So if you put this learning rate, the model will learn very quickly, but the performance may not accurate. Right? Why? Because you can take the example of your class where you are going to learn something. Suppose the table of 5 or table of 10. Suppose your teacher is capable to explain everything in 10 classes, and in 10 classes everybody will learn. Now if I say that your learning rate is maximum to the 1, right? So it might be chance you will learn faster, but because you may have not seen the unseen data, so the performance at the runtime may be degraded. Okay, so this is how we choose this learning rate. So always try to, yes, always try to pick the right value, but the right value pickup is not possible, but we will deal with this. Okay. So what is the matrix? So here the matrix will be using, we will be using the accuracy. Okay. So number of training sample. So in this session, in this cell, we have seen that 110 images belonging to 5 class, which is the training data set, and we have found 36 images belonging to the 5 class, which is for the test or validation set. So we will be passing the exact number here and be train sample and be validation sample. Okay, and number of epochs we have chosen 10. So you can increase by 1,000, you can increase by 10,000, you can increase by 1 lakh, but it totally depends on your configuration capability of a system and the amount of data size you have. Okay, now this history will store the model fitness through this train generator, number of epochs, validation data, and validation step. Right. So we will be observing how much time it is taking from this start. So we have put this, we have used this import time, start time, and end time. In between these, we have put up all this model training, right? So let me start with this. So probably it will take time, but I have set this epoch as 10. So maximum 2 to 3 minutes will be taken. If you increase the number of data samples, or if you increase the data size, or if you increase the epoch, number of epochs, this will take definitely a larger time. Okay, so let me execute this. So this is the blank, so it means it has not run yet. So let me run it. See, this is the star. Okay, it means it is in current execution. So epoch 110. So 10 iteration, you can observe this. So it is not guaranteed that after this training of model, the accuracy will be high. We will see how this model has been trained over this number of configuration parameters. So quickly it will be, yes, within 2 or 3 minutes. So meanwhile, you can ask any question in the chat box till this finishes. So you can apply this type of classification in any of the application, like whether it is medical domain or in the agriculture domain, to identify the leaf diseases among multiple or multi-class problem. Some of the cancer detection or corona detection in lung cancer images and lung images, and some type of cancer detection, you can classification, you can apply classification in that process also. See, so we have supplied it to the 10 epochs, and probably, yes, 83 seconds, probably, yes. So in 1 minute, probably we have completed this model training. Okay, right. So it is showing that 10th number of cell has been executed. Okay, so it is done. Now the model has been trained, but how can we identify that model is, yes, model is effective or not? So we have to use some of the libraries which indicates our model performance. Yes, in the chat box, I have one question. Do we need to use any pre-processing for data set in CNN? Yes, definitely. If it is a standard one, like if it is a public data set where authors or the creator of the data set may already done with the pre-processing. So in that case, you do not have to apply pre-processing techniques, right? But if you are going for the raw data set, image data set, you have collected it from somewhere, and probably your application may require some heterogeneous environment data processing, then probably the removal of noise or sharpening or clearing the blurriness. So in that case, you may need the pre-processing. Otherwise, in the standard case, they have mentioned that all the data has been pre-processed. So in that case, you do not require to pre-process it again. Okay. So this is the good question. Yes. So to examine how our model has been performed, has performed in context of data pre-processing or feature extraction, we have to make use of this libraries. Like, so we have started with PLT, which is the matplotlib library. Scalar, we have used matrix for the classification report and confusion matrix. Right, NumPy is obviously it will be done by default. So let me take this directly to the confusion matrix part. Okay, and we will see how this classification and graph will be represented. Okay, so let me run this. See, you can see this type of data, confusion matrix. Okay, so let me get to the graphical part. Yes. So we have 5 classes: bacterial spot, early blight, late blight, leaf mold, healthy. Right. Similarly, at the vertical level, it is also written like this: bacterial spot, early blight, late blight, leaf mold, and healthy. Right. But what exactly this color represents? So you might see that our particular model is not performed, is not trained very well. Why? Because you can see this color represents the 0, and whereas yellow color represents top. It means you can identify that given of the total number of images, how many are accurately classified. So there is the confusion matrix. So let me take to this confusion matrix definition. Okay, yes. So this is the predicted class and this is the true class. So whatever we have observed in this, it is a true class and it is a predicted class, right? Now, the first one is true positive, while the second one is false positive, false negative, true negative. So you already know the definition, but in this case, we see that tomato bacterial spot, either early blight or late blight, is not going to cover most of the portion. Only the leaf mode class, which is slightly correctly classified. Okay, so for this range. Okay, so we will see this one by one. So let me take to this model training graph. Once you see this, you will be observing that, okay, this is the accuracy, this is the precision, this is the recall. Okay, so let me run this. Yes. So using 10 number of epochs, so this is the accuracy graph and this is the loss graph. You can see, sir, this training accuracy is going high from 20 to 60%. Okay, no issues. But the validation accuracy graph downfalls from the 30% to the 20%, and it is going steady. See, we can observe this. The training accuracy graph is going from 20% to 60% in 8 number of epochs. But the validation accuracy is going down from 30% to 20% and then becomes steady. So what does it mean? Is the model we have trained is a good trade-off, maintaining a good trade-off? No, because training accuracy is that what you have trained for, but the model learning capability, the feature learning capability of this model, this graph, through this graph, we can see this is the big issue, right? So let me take to the another example where we have extracted the number of features like this. Let me take this. See, I will show the graph and then you will observe how these things can make difference. See, you can see the training accuracy and validation accuracy meets approximately and are closely related to each other with the accuracy of 90%. Okay, so what does it mean? If there is a big gap between this training and validation accuracy, you can simply understand the problem of overfitting. This is the problem of overfitting. So how to resolve this problem of overfitting? So either you can increase the number of data samples because the model is not getting significant features from the data, because we have the less number of amount of data. Right. So to maximize this accuracy and make this gap very reducible, we have to make the data samples high. And yes, yes, the number of data samples should be high, right? So this is the first thing. Second thing, you can see the less fluctuation over here. It means the network is stable. Yes, in the few epochs, you cannot determine how this will be fluctuated. Okay, so you have to run it for more than 40, more than 100, more than 250, or more than 1,000 samples for number of epochs, because it depends on the application and it depends on the data size. So if you have a large number of data samples, you can reduce it by some amount, some fixed amount, or if you have less number amount of data, then you should increase this number of epochs. It is same for the loss graph. Now let me run this. How we can see this model. So whatever the model we have saved, we are naming it plant 5, and in this session, in this cell, when we run, it will randomly pick the data and try to classify. Now we see that our classification model is not appropriate, is not effective as of now, right? So we expect, see, this is, so the predicted category is leaf mold, but the true category was leaf blight. So it is a misclassification. This is the true classification of leaf mold. It has predicted the category as tomato leaf mold, and the true category was also tomato leaf mold. This is the same. Okay, our model is accurately, but it is a random. Okay, so it is of bacterial spot, but it has identified as leaf mold, bacterial spot, leaf mold, healthy, right? So this is the runtime execution of this classification. So what you can do, to make it more accurate. So what you can do, you can change the number of parameters. Like in the last session, probably Dr. Dheeraj Prasad Sahu has explained the significance of hyperparameter optimization and tuning. Right. So what are the hyperparameters? So there are a number of hyperparameters like image size, batch size, right? Number of epochs can be a good a significant hyperparameter, right? So the selection of optimizer is also so where we have put this, yes. So number of optimizer, selection of optimizer may play a good role in context of getting a higher accuracy, right? Number of learning rate, yes, definitely learning rate, yes, that definitely a learning rate is a high. Yes. Thank you. So the learning rate is playing a very good role in context of hyperparameter optimization. So different loss function, different optimizer, different metrics, different batch size, different functions. Like, so if I take 3x3, definitely the operation will be different. So let me take this opportunity to run it again. So 3 by 3. So let me take this 64. The time can be more. The time can be lengthy, but let me use this. Okay. So it is running again. Meanwhile, you can ask some questions. So number of convolution layers, adding number of convolution layers will definitely increase its performance, its training behavior. But at the same time, it may degrade the computation. It may increase the computation complexity also, right? So you have to keep in mind. So the frequent uses of convolution layer, yes, definitely is going to increase the performance, but it may also introduce some of the problem like Tripathi sir has discussed, like vanishing gradient or yes, gradient issues, yes, or exploding gradient. So the last time we see that bacterial spot, sorry, the leaf mold was very accurate. This time we see the healthy plant was very accurate. So the performance, see, there is some high rise between this validation accuracy, right? Last time this has been started with 30% and it goes to 20%, right? Now some spikes or some fluctuations exist in this type of change. So you have to change this model training parameter accordingly to get the maximum benefit of this training like this, okay, or like this. So this loss and accuracy graph will decide how your model is performing, right? So this is the first part, I think. So probably I understood that image classification has been carried out from this moment, and we have classified 5 number of classes, but the model performance is not very well. But we can tune our model design so that we can get the maximum accuracy. Now, so this is the road classification network, what we have I have been performing since yes. So this model cannot be applied directly to the this tomato leaf classification disease, because this has been trained on different type of data set. Yes, so based on the transfer learning approach, you can definitely be applying this model to this model, but it is a slightly different concept. So using convolutional neural network, you go through this, right? Now the second part, which is the custom object detection. So it is the very useful object detection scheme we are going to see. Now, for example, face detection, I require some of the face images. So I have randomly downloaded the face images. So probably you are seeing this, okay? So probably you are seeing this. Yes. So this is the face data set. So yes. So there are a number of faces in the images of different persons, right? So in the last experiment, we have seen that how to classify an image. Now, the basic difference between classification and detection is the amount of localization. So detection means classification plus localization. It means you are localize the image. You are targeting an image. You are targeting an object in the given picture or given image. So if it is a large image, so suppose this image 161, so a lot of portion is covered with this background economy. Now I have to locate this object because the face is here, okay? So the entire image cannot be classified as face, right, or cannot be detected as face. So I have to locate this face. So what scenario, what scheme I will take from this example? I have to supply this face information to the model so that it can learn this type of face information from the images automatically, right? So probably you have understood what we are going to do like this. So there is some other person, like it is containing hand, it is containing racket, it is containing face, it is containing t-shirt, it is containing bottle, it is containing some of the other person in the background, but we have to search for the face. So what we will do, we will manually extract the face, and this face information will be supplied to the model so that it can identify this, okay, this is the target I have to look for, and the significant features will be accepted on that basis, okay? So for this, yes, so for this, Yes, for this, we have to use some external application. So I'll call it label img. Okay, label img. So in the second link, you can execute it, label img, and you download its highest version. Suppose Windows V 1.8.0. So I have already downloaded it. Now I will be going to this label img folder. So if it has not been displayed, please notify me. Okay, let this label image open first. Yes. Yes. So this label img is open, right? So this is the link, this is the platform, this is the framework where you have to supply the face information to the model. So you have to supply the face data set from this place. So you are going to select folder which contains your target images. So open directory, FTP, face dataset, you select folder, and you want to save the same data into that folder. So we will use the same folder. Okay. Now, so I have already performed some of the operation. So let me do it again for you. Right. So now suppose this is the image. Okay. So what I will use? So I will use default label. Suppose face. I will use, so let me view auto saving. Yes. So create a rect box. So I have to put this bounding box information like this, right? So it is the face. So I have started with this or this or this or this. I have started with this and I have enclosed a face from an image in a box. We call it face, and this file information, this bounding box operation will be saved. And how it will be saved, I will demonstrate you. So right now we are going to create some of the faces. So this is again, so you can do this. The next image, create react box. You can do this. All these things are face. Do this. Create a rectangular box. Create face. Right now, this is the only one class. So basically, an object is we are enclosing within the bounding box is a face. What about other part of this image which is outside of the box? So we call it non-face object. Yes. So for this, we suppose we take a hand. Okay. So let me delete this. So let me call this non-face. Okay. So create non-face images. So this is non-face. This is non-face. This is non-face, right? This is also non-face. You can enclose. So you have to supply the true class as well as false classes in your data samples. Okay. So non-face, I have to remove this. So it is a manual annotation. We call it manual annotation, and probably it may require a high amount of time. Okay. Similarly, non-face to create anything that is not the part of face, you can call it non-face. Okay. So let me close. Right. So once I have done this, so this operation will create an XML file of each of the corresponding images, and I will show you how this images will look like, how this data information will look like. So actually this is the XML annotation, XML file. This is the annotation, right? And the face we have set. Let me take another file. We have categorized two faces, two classes, face and non-face. So here the bounding box information describes the X minimum position, Y minimum position, X max position, Y max position. So bounding box is described by 4 position, right? So we can observe that, okay, so this information will be sent to the model, and this model will be learned, this data will be learned, like here face. Suppose this image contains 2 faces. So this is the first face, right? And this is the second face, right? So you can see the different coordinate points, 58 to 63, y min 15, 21. So depending on the face position, it will examine how the face position are given in the pixel. Similarly, for the non-face example, so non-face example may have different position, right? So whatever the positions you have went for a face position or non-face position, it will record everything, and then this XML file will be supplied to our model. So let me go to this. Okay, so let me take to the face detection part. Okay, so again, so it is simplest thing. So the additional thing what we have discussed here, it is the XML parsing, because the entire file, now this time we are not reading the image. In the image classification, we have gone through reading of number of samples in the given data set. But this time we are not going to read the image data set. Instead, we are going to read the XML part, XML file, because we have supplied the face information from the image and saved it to the XML file using this label image operation, right? So you can see this type of some computer vision library, some operating system library, NumPy is NumPy, PLT, PLT1, right? Some of the categorical and SQL model. So let me directly take those execution so that we may have the better understanding how these things are actually happening. So if a program displays nothing, it means you are not displaying anything, or the program runs well. Okay. So the same thing I have written over here with different type of operation, right? This is the simplest operation, model sequential, but I have called using the build model function. You can create your own defined model where the width, height, depth of the image will be passed, and the number of classes you will pass. So there are 2 number of classes. So actually this is not the classification problem, but there are 2 classes. First one is the face and second one is non-face, right? So height, width and depth is passed. So height, whatever the height, whatever the width, depth is 3, definitely color, and the classes will be 2, right? So some of the position we have defined this. Let me take you to the particular classes. So see this number of classes is 2. Depth, yes. Number of depth, it means the color channels are 3. So width is nothing but the resize and resize. So we can identify what is the value of resize. So it is 28. So we are approaching to 28 cross 28, comma 3, and the number of classes is 2. Right? So input shape is 28, 28, and 3. And based on this, so please leave this. Based on this, you can perform any number of operation starting from convolutional activation max boolean, then convolutional activation max boolean. Here you can use flatten dash activation, dash activation. Till now, we have not used some normalization function like batch normalization or L1, L2, but we will see how this will impact, this will affect the performance of the network. Right now, we have to read those XML files. So this is the model definition here. This is the some of the files or some of the methods calling. Now we have to read some of the XML files where we have saved, right? So for this, we have used XML parsing. So file name from the OS, because we know that OS is used for listing the directory and locating the directory. So we have utilized this OS for this. So it will parse the full name as a tree, and it will identify the object. So if you closely observe, you will find that these type of XML file, these type of object XML file containing an object definition, right? So in context of HTML programming, you see the tag, it has started with object and it has closed with /object. So entire thing enclosed within this object tag will be processed when we supply this information to this model, right? So it is of one object. So let me call some of the file. Right? So here object, the face is object. Okay, one object, then another object, another object, which is one for separate object, and then finally fourth object, and most finally the fifth object. So whatever the classes on face or faces you have used in the label image application. So ultimately you have to process this object file. Okay, so let me go. Yes. So we have to find an object and then bounding box. So BND box. So let me take again. Look at this. So it is searching for bounding box. So under the object, you have two categories. Either it can be face or it can be non-face, and the actual information in the context of positional information, it has been enclosed within the bounding box. So inside object, you have to process the bounding box, and ultimately you will classify this as face or non-face. Okay, so we have already seen this classification. Let me, yes. So we have already seen that custom object detection or simply object detection is nothing but classification plus localization. Okay, so we are classifying two objects, which is face and another one is non-face. Okay, so if name is face, it is labeled as 1, and if it is non-face, it is labeled as 0. So ultimately xmin, ymin, xmax, ymax will be processed, the positional information will be observed, right? So let me run this. So you will see the number of samples, how this is processed, right? So if you see, so let me open this image 324.xml. It will have 4 information, okay, 5 information. So we should cross verify image 324. Okay, so let me share this again. Yes, image 324. It has 5 information. So first is face. Okay, so starting with this one face, second, third, fourth, 5. Okay, so the first position information is 58, 15, 148, 128, 58, 15, 58. Wait a minute. Yes, yes, 58, 15, 148, 128. So this is the same. Okay, so we are going correctly in this direction, right? So once we process this XML files, all the information now comes under the category of data. Now data, we have labels, we have data in terms of numerical values and labels in terms of phase and non-phase. Okay, now we have to process this data and associated labels. Right, so we have splitted the data, it means the entire data, into two parts. One is training, train X, train Y, and testing, test X, test Y. Test size is 0.25. It means you have splitted the training data size into 70-30 ratio. Accordingly, we have divided this into 75 to 25 training. So 75 training and 25 testing. Right. So it is the categorical where number of two classes are represented. Some data image generator, which is nothing but the data augmentation. We have to amplify the number of data samples, then model fitness, and then printing. So let me directly execute this. So it has been okay. So build is not defined. So let me clear all the screen and do it again one by one, because we have not executed this build cell. Okay. So this is okay. This has been executed. So I will leave one portion of this application for you. You will execute that thing, and probably you will be executing that thing. Okay. So this application runs for 500 number of epochs. Okay. Learning rate is 0.003. Batch size is 32. So the number of 500 epochs will take some time, but definitely because we have less data sample, it will be executed very fast. Okay, so you can see the number of accuracy parameter from this place also, but don't believe into the quantitative score. You just examine what is the qualitative behavior of this model is representing. Okay, because fluctuation may represent some different type of features. Right now, if you see this numerical values, you will find, sir, the accuracy has come on 84, right? 84.62. Sometimes it has reached to the 92. So can we say this accuracy, the model accuracy is 92, so our model is good? No, you have to discuss the pattern it is following. See, the number of 500 epochs, the fluctuation is very high. It means the network is not stable. The network may represent the correct classification, or the network may correct incorrect classification sometimes, right? So for this, you have to maintain the gap between this training and validation accuracy, right? This is the loss, this is the accuracy. So you have to maintain, the first thing, you have to maintain the gap, reduce the gap between training and validation. Second thing, you have to reduce the fluctuation which you observe in this graph. Third thing, as soon as you get the highest accuracy and less number of epoch, your model performance can be set to the very effective, right? So I have demonstrated through this road classification network, one of my project, where I have achieved this. Yes. So this is the thing you have to maintain. The minimum gap between the training and validation accuracy is the first requirement, so that it can avoid the overfitting. Second, less number of fluctuation will be definitely describing the stability in the network. And the third one, if you achieve the highest accuracy in the few starting epochs, then your model is said to be very effective, because it has learned the significant features very quickly, right? So this is all about the object classification and object detection. One part I am putting on you, that you have to discuss, you have to make an application based on the model defined. So like this, we have classified in this type of leaf detection. So the code is there, you have to execute it by yourself, and you will be using that type of object for face detection application. Okay, but however, I have written the code here. If you don't find comfortable with your own coding, then you can definitely use this code because I have already fixed on this. Okay, but don't go for this. Start with this type of whatever. Okay, so I am open to the questions. Whatever the technical session I have covered in this session, technical session, not theoretical session, I will be answering. So if you have any question, you can ask me. Still we have time. So I am open to the questions.
Hello. Respected participants, if you are having any query, you can raise your hand or you can directly ask in the chat box. If you raise your hand, I will unmute from here so that you can speak directly to the sir.
So no questions till now, but yes. So let me pick the questions from the participants, starting from this.
Participants, if they are having any question, they raise their hand.
Yes, so for the first question is, what is cafe, sir? Okay, so as of now, we have seen the implementation using TensorFlow and Keras library made by Google. So there are a variety of libraries are available in the market where you can, if you're not comfortable the styling or the compatibility issues of TensorFlow or Keras, you can go for the different implementation libraries, like which one is Cafe. Some other implementation part is also there, like PyTorch, right? So there are different variations and different application target area, and it depends on the application and their and the system requirement of your model, right? So Cafe is a what you can say the small scale package where you do not need to very much require some of the memory or some of the hardware is a specification. So for the small scale environment, you can use Cafe, but obviously Google is approaching and expanding its implementation. So generally TensorFlow is the base for the beginners, and once you are comfortable with TensorFlow, you can go for the PyTorch and other versions of this, like you have asked for the Cafe. So Cafe is just a library where you can execute the similar things, either object classification or object detection. There is nothing much different, a marginal difference between them. Okay. So the second question is, yes, Cafe I have read. So a new message. So 256, is there any significance in number 256 in there? No, there is no significance in 256 number of decimal here. So it depends on the application and the number of the complexities you want to manage, because the number of nodes or number of dense you create, it will create complexity. But at the last layer, in the dense layer, you will describe it by number of classes, right? So if you have used what 256 or 56 or 25 in the previous layers of dense layer, you will not be able to create the similar things in the last layer, because the last dense layer will describe the number of classes. Okay. So do we need to use any pre-processing for dataset incidents? So I have already explained this. Yes, so I'm expecting more questions. So we have if you are going to do some research, or in the research area you want to implement CNN, so basically this is the approach where you have to collect the data. If it is a public data, then, and if it is pre-processed, then you do not require to pre-process the data again. If it is not pre-processed, you might be applying some pre-processing technique like image processing of noise removal, or deblurring, or sharpening, or strengthening the image size, like this. But generally we do not require. So if you're taking the raw data, yes, definitely it requires. The second thing, the design of the model. The design of the model, you have to design your model in such a way that it will achieve all the three things I have explained. Reduce the gap between the training and validation accuracy. Then less fluctuation. Then third, getting the highest accuracy in few number of epochs. It will be more beneficial if you achieve this. Okay. Okay. So chat box, question and answer, no question answer, chat box. Yes, so if there are more questions, I'm happy to respond. So this is not the issue associated with the CNN model designing. Okay, there are a lot of issues like the hyperparameter optimization is taking lead in this CNN, because you cannot determine which learning rate or which optimizer will definitely will increase the performance, right? Even this kernel size, or how this number of convolutional operation can be fixed, you cannot determine manually how this number of epochs, because it might be possible that at 250th iteration you will get the maximum accuracy. So why to run for next 250 iteration, right? So some meta-heuristic algorithms can be applied to find out the significant number of hyperparameter, and in the similar fashion you can define the learning rate, you can define the batch size similarly. Yes, right. Yes, so I am open. If you feel comfortable, you can ask me.
Participants are requested, if they are having any query, they can ask directly from the sir. We will be very pretty happy if you ask some question.
So I will send these files along with the path to the data set where you can download the data set, and you just have to change the path. Okay, you just have to change the path where you have saved, and it will automatically start executing the classification task and the detection task. Yes.
Hello, sir.
Preeti ma'am, you are having question. You can ask from the sir.
So if you feel this session will help you, then definitely send me an
Preeti ma'am?
acknowledgement.
Yes,
Either it
yes,
is
sir.
positive or
Yes,
negative.
please ask.
If it is negative, I will consider this in the next improvement. And if it is positive, then definitely it will boost up my learning style.
Hello.
And if you have some specific question regarding to your project and other things, I will be happy to help you, because I have been working in
Deepak
this
sir,
field
Deepak sir,
since
sorry to interrupt
2018.
you. We are having one question from the Preeti ma'am. You could answer.
Hello.
Preeti ma'am, yes.
Sir. Hello.
Visit this page.
Deepak sir.
And you can identify that this type of application where I have applied deep learning and convolutional neural network based application.
I will send the
or
question
different
in
type of applications in autonomous vehicle system, and probably it will surely help you